Hello friends, and welcome to our new class today. We'll be looking at vectors. Vectors are defined as quantities that have both magnitude and direction, right? And they are the opposite of scalar quantities. Scalar quantity has magnitude but there is no direction. Now, recall that anytime we are to represent vectors, we say that quantities that have both magnitude and direction. So they're represented as this. This is what magnitude, and this cap here means direction. So this is magnitude and this is direction. That's the reason why anytime you have to represent vector quantities, you have to show that this is magnitude and direction. Now, we're going to be looking at vector representation. Vector representation. Vector can be represented in different ways. That is the method of finding vectors when they act at different positions. Now, we look at one, when vectors act in the same direction. Now, when vectors acting in the same direction. Vectors acting in the same direction. When vectors act in the same direction, the resultant vector is simply the sum of the two vectors acting at that point. Now, let's consider this as an example. Let's say this is a block of wood, and two vectors acting on this wood. Let's say two vectors are acting on it. This is called vector A and this is vector B. When they act on this, they produce a resultant vector which is in the same direction as the two vectors acting. So the resultant vector here, the resultant vector, which we can say is I. To get it is simply the sum of the two vectors. If R will be equal to A plus B. That is how to find the resultant vector. And what is going to be the sum of angles here? Sum of angles, that is the sum of angles when vectors are acting in the same direction is equal to what? 0. Don't forget it. Don't forget this. This is very important. When vectors are acting in the same direction, then the sum of angles is equal to 0. Now let's look at the second case too. When vectors acting what? In the opposite direction. When vectors are acting in the opposite direction, let's look at this an example again. When vectors are acting in the opposite direction, let's say vector A is acting this direction, let's call this one A, and vector B is acting in this direction, right? Now, what is going to be the resultant vector when the two vectors are acting in different directions? That is, A is opposite B. The resultant vector is going to be dependent on the strength of A and B. If A overpowers B, that means the direction will be this side. But if B overcomes what A, the direction is going to be this side. So the resultant vector R here is just going to be the difference between A and B. That is going to be A minus B. For when what? When A is what? Greater than B, right? But the resultant vector is going to be B minus A. That is when what? When B is greater than A, right? That is how you represent that, so that we can get positive value. And what is going to be the sum of angles? Sum of angles, don't forget this. Sum of angles on this is going to be 180. When vectors are acting in the opposite direction, the sum of angles on it is going to be 180. And the direction of the vector is dependent on the strength of A and B. If A is bigger than that, and is going to be in A direction. If B is bigger than A, is going to be in B direction. So that's it. Let's look at the second. Let's use this to find an example. Let's look at an example. For instance, example, let's say this is example 1. For instance, you have this block, right? This, right? Now, if vectors B and then this is vector A are acting on it, let's say this is 20 Newton and this is 30 Newton, and you have to find the resultant vector. Let's say find the resultant vector. Find the resultant vector here. The resultant vector is simply the difference between what? A and B. So R here is going to be what? It's going to be B minus A, because B is bigger than what? A. And that is going to be 30 minus what? 20 Newton. And if we do that, it's going to give us what? 10 Newton. And then what is going to be the direction of this vector? The direction is going to be this side, because B is bigger than A. That means if both of them are pushing on this, B will overpower A, so it will move to this direction. So the direction is going to be like this. The resultant vector will be in this direction. Now, don't forget that. Now, let me give us another example. Let's give us another example. For instance, you have this. You have this. Two vectors are acting on it. Let me draw it very well. Let's say you have this, and then two vectors are acting here on this block. So let's say this vector A and vector B. This one is 20 Newton and this is 50 Newton. Recall that the resultant vector will be produced at the ends of this, because those are pushing that side, the resultant vector R. To find R here is a simple what? The sum of what? A and B. So the resultant vector here is going to be 20 plus what? 50, and that is going to give us 70 Newton. So that's how to find what? The resultant vectors when they are acting in opposite and in the same direction. Now, let's look at a case when vectors are acting what? Vectors, that is case 3. Case 3. 3 vectors acting in or should we say on the right angle triangle. On the right angle triangle. Or can I just say that vectors acting perpendicular to themselves or perpendicular to themselves, right? Now consider vector A and B. If vector A, this is a straight line. When we talk about perpendicular relationship, is when a straight line, a vertical line meets what? A horizontal line, right? Now if two vectors are acting in this form, let's call this vector A and this is vector B. You have that they will form a perpendicular line here because they will be acting in this right angle triangle. And they will consider this to be the hypotenuse, right? So the resultant vector is found at the hypotenuse, and then the direction of the angle theta is here, but you can still represent it there. What is going to be, let's say this is R, and yes, this is A and B. The resultant vector is simply to use what? You use the Pythagoras theory to resolve this, to find the resultant vector. So R here is going to be the square root of what? A square plus B square. That is how to find the resultant vector when vectors are acting in the what? Opposite direction. You apply the what? The Pythagoras theorem. While the angle theta is going to be, the angle theta, you just use the tan of the angle, the tan inverse to be able to give us the angle. So the angle theta here can be theta, that is tan. Theta is going to be opposite over adjacent, that is A over B, right? That is going to be tan theta. While you can take tan theta as a tan inverse, right, to get the angles. So you see that when vectors are acting perpendicular to themselves, the resultant vector is gotten by using the Pythagoras theorem. I know that the resultant vector is on the hypotenuse side. We use the Pythagoras theorem to get it, while the angle we just apply trigonometric ratio to get it. So let's use an example. Let's say this is an example. This is a vector, right? This is vector. This vector, let's say here, always show this arrow, show the direction of the vector. So this is 3 Newton, and here is 2 Newton, and theta here. So we can say find is a resultant vector. Find R and what? The angles. Find the resultant vector and the angles. You already know what to do now. From here, you can just say that the resultant vector is going to be the square root of what? 3 square plus 2 square, right? And that's going to give us the square root of 3 square is 9, right? Plus 2 square, that is going to give us 2 square, that is 4, right? And when you add that, you're going to have 13, the square root of 13. So you're going to have the square root of 13. Let's take this away. That means resultant vector is going to be the square root of 13. So you take the square root and you find the answer in what? In Newton, right? You see, find the answer in Newton. Then the resultant vector, that is the resultant vector. So the angle, which is the direction of the vector, is found by taking the tan angle, because it's opposite here and adjacent here. So we can say that tan theta is going to be 3 over 2, right? 3 over 2. 3 over 2. So we'll just, from here, we can take the tan inverse, right? So we'll have that theta is equals to the tan inverse of what? Do you actually know how to take tan inverse? Tan inverse. Tan inverse, it simply means that anytime you have to find this, some of us don't know that you have to divide both sides by tan, right? That is what is tan inverse. Divide both sides by tan. When tan cancels tan, theta will be equals to 3 over 2 divided by tan, right? So you add 1 here, so the theta will be equals to 1 will come up here, we'll have 3 and tan will multiply 2 here. We have 2 tan, right? That's what we're going to have there. Then this can be the same as 1 over tan multiplied by 3 over 2, right? And then this is tan inverse, so theta will be equals to the tan. Anytime you have 1 over a is the same as a inverse. So 1 over tan here is the same as tan inverse. Tan inverse of what? 3 over 2. When you press that, then you get your result for theta. So that is how to find the angle on the angle for vectors. That is the direction for vectors when they're acting in perpendicular to themselves or on the right angle triangle. And then how to find the resultant vector. So just for you to apply the trigonometric ratio for the direction and then the Pythagoras theorem for the resultant vectors. We will be dropping more videos on vectors acting at the parallelogram or parallel to themselves, and then vectors acting, more than one vectors acting at the same point. We're going to drop videos. Don't forget to follow us so that you can get them too. Thank you.